Hey everybody, we are here and we are here to help. So if you log in right now, we can do some assignments. I've got the availability to do my Pearson assignments. It wants to show pop-ups. Let's log out of this right here. We're gonna pull up the My Pearson. I'm gonna bring down the My Pearson page. So let me get My Pearson up and running. Some people might come in while we're doing this right here. So let's bring up My Pearson. I think that'll be the topic of the day, will be a lot of My Pearson work. So I'm going to bring up My Pearson and we are going to do some My Pearson assignments. So if you are here, and we might have some people joining in right now, say hey in the chat. You don't have to, but if you are, you can ask a question. You don't have to use your real name. You can use a fake name, log into YouTube with any name you want, and ask any question you want related to statistics. We're just here to help and do statistical problems right now as I get some of the assignments loaded up right here. So let's see, is anyone in the chat? Do we have anyone in the chat? We see people in the chat. I see some people. How are you doing? The p-value for the normal curve. Is this a 201 question? Like, how do you know if something is normal? And chapter 7 question. Good to see everyone here. The chapter 7 quiz, people are saying, does anyone have a specific problem? Like, Brian, can you work this problem in chapter 7? And so good to see everyone. I'm pulling it up right now, so I'll be able to see the chat again in a moment. But so good to see everyone. I see p-values with the normal curve. I think I can explain that. This is a 201 question, right? Because in 320, we go a little bit deeper. So if you are talking about 320, feel free to say that, and I'll go deeper into the topic if this is a 320 question. So, and I think Sean is saying, yes, this is a 201 question. So when it comes to p-values and the normal curve, let's just talk about that briefly here, and then we'll start doing some chapter 7 calories and fat problems. You got it. We're going to do a bunch of those chapter 7 problems. It looks like chapter 7 is the topic of the day. So let's talk about the normal curve for a half second here. Now, one thing you should do when you do a null and alternative is you should start out here with your null and alternative. We don't stress this as much at the beginning, but this is going to help us for later on. The null is going to be normal, and the alternative is going to be not normal. Now, this notation I'm writing right here is H sub O and H sub A, where H sub O is what the null states. The null states that the distribution is normal. The alternative states that the distribution is not normal. So we need to make sure we understand what the null is. Now, what do we mean with p-values, and what do we mean with the null being true? Well, if the null is true, what should we see? I just want you to look at this null. I want you to look at it and say if the null is true, we should see a distribution that looks normal. So this is what we should see, as in if the null is true, you should see something that looks kind of like this. It doesn't have to look just like it, so mine's not perfect, but it looks kind of normal, as in if you fit a curve on top of this, it'd be unimodal and symmetric. So that's what we should expect to see given the null is true. What do we not expect to see, what is unlikely given the null is true, is something that is very skewed. Now I want you to hear the wording I just used. I said if the null is true, we would expect to see that top distribution. We would not expect to see the lower one. So what would we do here? The top one would get a p-value, probably if we do a p-value here, equals to, space pen, gotta love space pen, equal to something like 0.71. And space pen, do you guys like space pen, or is it too hard to see? I'm always worried space pen's too hard to see. Well, let's do it with the red pen, 0.01. We are going to do My Pearson coming up here in a moment. And then this one here is unlikely given the null is true, and this one will get a p-value of like 0.00001. So when you think about this right here, what are we saying? Let's give these numbers. Let's give this, we'll give them letters, graphic A, graphic B. So with graphic A and graphic B, and I'm going to put the letters next to it, this is, because there's always the null alternative, graphic A and graphic B. That's B0 to understand. Graphic A shows a normal curve that is highly likely given the null is true. As in, what we observe in graphic A is highly likely given the null is true. So you would continue to believe the null, i.e. fail to reject it. Where graphic B, the one below it, let's highlight graphic B. In graphic B, we see something that is unlikely given the null is true. So who here can tell me what we would do to that null since it is unlikely the null is true? Since it's unlikely the null is true, we would what the null? You would say, Brian, I'm going to do this to the null. You can only do two things to the null. And this is what we're going to do. Since the p-value is low, telling us what we saw there is unlikely given the null is true. Master, nice answer in the chat. Reject the null. We're going to reject that null and say I have evidence that B is not normal. And just look at it right there. B looks pretty not normal, and we have evidence it's not normal because what we saw was unlikely given it is normal. Does that hopefully help make more sense of it? The biggest thing here, and I'm going to do one more thing on this, and then we're going to hop right into my Pearson assignments. Lots of my Pearson questions coming up right here, is you can actually do the same sort of null and alternative thing with correlation. I think correlation has 2 R's. I finally, after many semesters, have learned how to spell correlation, but I don't know how to do the null. The null with correlation is no correlation. I was so trying to write no correlation right here, or write correlation, that I forgot the no before it. And the alternative is correlation. There is a way to write this with statistical notation for any stats people watching this later on. It is technically that the true correlation is equal to 0. It's that rho is equal to 0. We don't use notation at this moment for this because we don't really talk about the null this much. But if there is no correlation, how do you write the straight enough and plot doesn't thicken condition? Oh, we just do QQ straight enough, no outliers, plot doesn't thicken. Those are the conditions right there. And we don't have to write those out with nulls and alternatives. So those won't be written with nulls and alternatives because we don't actually do a p-values on those yet. 320, we get into p-values on some of those. So this one right here with the correlation, if there's no correlation, I want you to look at this graphic here that I'm drawing, and what does it look like? In this graphic right here, there's no correlation. And in this graphic down here, we're going to put a really strong correlation. So in the lower graphic, there's a really super strong correlation, which would be if this occurred, if the bottom graphic occurred, that would be unlikely by random chance given there is no correlation. So in the bottom one, it's going to have the low p-value again, telling us what we observed is unlikely given the null is true. If there is no correlation, what I observed right here is unlikely. So what I'm going to do, I'm going to say I reject that there's no correlation. I have evidence that there is correlation. Listening to the key wording for help later in the semester. I reject that there is no correlation. I have evidence that there is correlation. Now for the top graphic right here, this one I'm pointing at right there, we're going to have a high p-value here, and the high p-value of 0.71, these are just made up, and it's a high p-value, i.e. above 0.05. We'd say I do not reject the null here, I do not have evidence of correlation, or I fail to reject the null, I did not find evidence of correlation. So in this instance, we're basically saying we continue to believe that there's no correlation. And then kind of look at the result, which I highlighted there, to see if it kind of makes sense for it. The thing I wanted to highlight here that's very important is when we do nulls and alternatives, there's a different null and alternative for each test. So when you do normality, the null is normal, the alternative is not normal. When you do correlation, the null is no correlation, the alternative is correlation. And then we look at the p-value to tell us what to do with the null. We will either fail to reject the null for high p-values, i.e. above 0.05, or 0.05 or above technically, or reject when we have p-values below 0.05 because what we saw was unlikely given the null is true. So we're like, well, this is not likely given the null is true, so let's reject it and say we have evidence that the null is not true. Let's hop into those My Pearson questions. Lots of My Pearson questions on the screen. And great, hopefully, Sean, does that make more sense right there? Does that help out with those questions? Does it make a little bit more sense right here? I hope it does. I see a lot of Chapter 7 questions. So let's go to Replace Questions. And let's bring this up right here. Okay, we got the questions on the screen. So I'm going to grab all the questions in order from the things. Yes, Sean. Thank you for the question, Sean. Really appreciate it. Let's make you a mod right here. You get mod powers. Amazing question. So let's hop into, I'm on Chapter 7 quiz. I'm currently having trouble with that. Yes, I need help with the Chapter 7 quiz. I'm on problem 4. So I see the first one I see here is they ask, can I work the calories and fat problem? So there's a few that do calories and fat. Hopefully I grab the right one. Let's grab a calories and fat problem right here. So this is one of my favorites. If someone wants that one, I'll come back to that one. This one's a tough one that a lot of people get stuck on. We can get back to that one too. Here's the price of cars. Done that one a few times. Here we go. Is this the one you wanted right here? I'll do every problem we see. Is this the problem people want right here? Can we get some yeses in the chat that this? Yep, this one. Good. Awesome. There's like another calories and fat one too. Let's talk about what this problem is doing first. It tricks you to start. So this problem starts out with a trick right here where it says the data show fat and calories for fast food hamburgers. Sounds excellent. A model is created that can estimate the number of calories in a burger. Now I want to point to something right here. When you see this, we're going to grab this and we're going to bring it into Microsoft Word for the moment as though it's our test. Always kind of treat this stuff as your test questions, and let's see what we can do right here. We're going to go over to Word. We're going to open a new Word sheet. We're going to go to Layout, and we're going to turn it sideways for the moment right here because we're going to put a big picture in here. Okay, cool. Excellent. Now we can draw on it. When I hear that this model is going to estimate the calories, does that make calories Y or X? When I hear it's going to estimate the calories, does that make calories Y or X? And I would do this on my test. I would be like, okay, we're going to estimate the calories. We're going to estimate the calories. So think, would that make calories Y or X? We're going to estimate the calories. We're not going to use calories to estimate something. We are going to estimate the calories. Would calories be Y or X if we are estimating calories, like predicting calories? If we are predicting calories, Y, you are totally right there. That makes it Y. I'd mark that on my test. I'd know that that's Y. And I know down below it's not Y. More on that in a moment. This makes fat X. So you get to the first question right here, which tries to trick you. Since we're estimating calories, calories would be what we're predicting. We're going to predict calories. And the predicted value is the Y. It's what we want to understand. It's like, why do burgers have calories? Well, let's predict it. Maybe the fat explains it. So explain why you cannot use this model to estimate the fat content of a burger with 600 calories. So it wants us to estimate fat with a burger of 600 calories. And if you notice, the issue is this. Right now, our model, the way they want to make it, is that calories is going to be the Y, but down here, calories is the X. So the model was made for predicting calories from fat, not the other way around. If you notice, that's the issue they're trying to point to right here, that they put it the wrong way. So at the top, the very top of the question, all the way up there, it's saying, let's make a model to predict calories from fat. And then it's like, well, here is the calories of a burger, now predict the fat. No. You need to do, if X explains Y, you need to put the X in the X position. So this is the problem, is that they have it flipped. You can't use the Y input to predict X. We need to do it the other way around. So that is the answer on that one. So now it says, look at the wording. It says, use the appropriate model. So now we are now doing it with fat being the Y. So interestingly enough, after you're done with this first part of the question, we need to add in like a white pen. So after you're done with this first part of the question, you can literally just ignore all this up here. So we're going to ignore all of this up here from now on. It's just there to trick us. And we should know from now on that with the remainder of this problem, what will be our Y variable? What will be our Y variable for the remainder of this problem? So just ignore the start of it. It's saying, oh, we're just going to flip them around now. What's going to be the Y variable? And so I'm going to write some important notation on here for us to practice. So what will be the Y variable here? What would be the Y variable? What is the name of the Y variable in context of the problem? And I'll give you a hint. The way we write the equation is Y hat equals B0 plus B1x. And what is the name of the Y variable? If you look over there where I've highlighted, you might see the name of the Y variable. The name of the Y variable is, for 1,000 points, who's got in the chat? Who's got it? The name of the Y variable is what? Oh no, I get stuck. I don't know the answer. I'll accept what answer you give. The name of the Y variable is fat. You are right. Nice job. It's fat because look, this is our Y and this is our X. So what we're going to do here is literally we're going to put fat right here and then we're going to put calories right here. Nice job in the chat right there. Sure, we'll do it that way. So it's fat and calories, and that is the name of the Y variable, which gets the hat on it, and the X variable. Now, the problem is people get stuck here because you need to get the coefficient of each of those variables. So we need the coefficients of each variable, but check this out. What I have, since we have everyone watching this, I'm probably going to do this in Jump, and everyone should have Jump on their computer from doing the project. So I'm going to do it in Jump because it's actually really fun and really easy in Jump. Let's hop back as I keep clicking the wrong screen. Let's hop back and grab the data. So we're going to grab the data right here. We're going to go copy to clipboard, and we're going to copy in our data. So we're going to hit Control C, that copies the data, or Command C on a Mac. We're going to jump over here to jump. That's what we do. Jump saying, check out the tip of the day. Sure, check automatically for updates. Do not check updates anymore. Okay, cool. That message has stopped me from using jump so many times. Calzone Tyrone. Oh my gosh. So good to see you. We have our Kahoot coming up on, that's Thanos. That's awesome. I got Batman could beat Thanos. So good to see you. We're doing some regression right now. We have a Kahoot coming up on Thursday. So you are welcome. 5 p.m. Thursday, first Kahoot of the semester, doing some correlation, some regression. So good to see you. You are a fan favorite, and I hope you're a fan favorite again this semester. So thank you for taking part in our class. So with this question right now, the first Kahoot of the semester, you got it. So, and we have some new stuff. We got speedrun stuff. Maybe I'll show that. Yeah. Oh, awesome. So get ready. So good to see you. Oh, and you're really going to like the intro. So be there at 5 early. I promise. With your wink, with your icon right there, you'll really love it. Okay. So back to doing this right here. We're going to paste in with column names. Now, here's the biggest thing. And please, someone, if you get stuck, ask a question, because this is where people make a mistake, is need to go to edit, paste with column names. And now we have the data inside of here. Please note that these need to be blue. Blue inside of jump means that they're quantitative. So we can only do a scatter plot with 2 quantitative variables. We can only do a scatter plot with 2 quantitative variables. And I will send you that card. I know where you're at. I will, if you win the Kahoot, I will send you the Starbucks gift card. So be there early. We might have random people everywhere playing the Kahoot. Like, I really want that Starbucks gift card. But you are a fan favorite, so you can be in the running for it. Maybe I'll buy another one. There might be 4 winners if you come in first through third. So that'd be awesome. Let's go right here. And does anyone remember? Let's go back in time now. We are predicting fat, which means it's the y variable, and calories is going to be in the x. Now remember, the question first had us doing calories as the y, but then it switches it to fat being the y. So it switches it around. So, and we even have better microphones this semester. Improvements. And so here is the model right here. Go here to the red arrow and go to fit line. How is everyone doing on this problem right now? Have people completed what I've done? I know. I hope we get a ton. That'd be so amazing. I'm gonna bring this over to jump right here so I can draw on it, and then we're gonna review. So let's bring this over to jump. Jump back in, jump. Okay, so here we are. We've got our model. First thing I want to look at with this is some QQ straight enough. No outliers, plot doesn't thicken. So if you are in my class, you probably know that pretty well. QQ straight enough, no outliers, plot doesn't thicken. What does that mean? Well, QQ means that fat and calories are quantitative variables. So this passes QQ because fat and calories are both quantitative variables. Pass that condition. Straight enough means that this red line, I'm going to highlight across it here, this red line is straight enough. What do we mean by straight enough? That it kind of goes through the middle of the data. You could have things like, let's pretend the data looked something like this right here. If the data had some weird pattern like this, then that red line would not be straight enough. So this is an example of not straight enough, but in our example, it is straight enough. So we are perfectly fine. That was just a counter example to show you not straight enough. No outliers literally means there's no outliers. Like if you had this right here, that would be an outlier, but we have no outliers. Plot does not thicken would look something like this is good. So this is fine. Plot has not really thickened anywhere. But if the plot gets thicker any spot, this is something we call heteroskedasticity, which means unequal spreads. You don't need to know that big word, but you need to know that the plot should not do this. You shouldn't see sort of like bands going out like this where it gets thicker and thinner in any portion. You don't want the plot to get thicker anywhere. So that's why I say the plot does not thicken. And our plot looks to be pretty good, as in our plot has not gotten thicker. Now, what you should notice is you have, that's the point that's actually there. What you should notice is we have the regression equation right here giving us B0 and giving us B1, and this is the x variable. Just to make it very, very clear, this is y hat equals, and this is B0, and on the next line is B1, and then that's times x. So it's technically, yeah, it's still a plus. The intercept is negative, and that's all right. And it's a plus because it's positive. So make sure you identify what's going on with this. I also wanted to point out this right here. There's some very important output right here, and I'm getting you test ready. Because when you look at this output, you should notice that this is the estimate of the intercept, this is the estimate of the slope, and this is the significance of the slope. So what you have right here is the p-value for the model. That's the p-value for the model, hence why it's connected to p-values. It's for the slope, it's for the model. And this is the coefficient of b1, and this is the coefficient of b0, which you'll notice up above. Like this is b0, and this is b1, and this is the x variable, and that's the predicted y variable right there. So know this output. Know your output. Know what it's telling you. Know what it means. This means that, well, you can't see what I'm pointing at. This means right here that the model is statistically significant, and I'm hovering over that right there. What I've highlighted right there is if the model is statistically significant, because that is the statistical significance of the slope. So we've got our slope, we've got our intercept, negative 16.418, negative 16.418, 3 decimals, negative 16.418, calories times calories. Where is that thing? Where'd it go? Where in Word? So calories is 0.085. I think 3 decimals. Hopefully I didn't mess up my decimals. And the regression was meant for predicting, so why didn't this work? Which one did I bubble? I know I got to correct why I bubbled it, and I'm like, just want to check my own work? Okay, I got to answer this one again. I think it was this one right here. Why would it not work? Oh, the model was made for predicting calories from fat, not the other way around, so we can't predict fat. So the original model, there's that. The fat content of a burger was 600 calories. You know what's the coolest thing right now? Here's what you could do. You can go right here, and you can take your equation, and we're going to go to this equation, and what do I do if I want to predict the fat content of a burger with 600 calories? I go here, and where calories is at, I replace calories with 600. So we can solve this ourselves the fun way. Okay, here we go. So we're going to do 600 times, and I would carry all my decimals, 854,188, and then we're going to add the intercept, which is a negative, so 16.41792. Yep, exactly, Julio, 1,000 points right there. So this should be the answer, but check this out. If you go into jump, and you go here to save predicteds, so this video can be rewound, it can be paused if I'm going too quick at any time. We go here to save predicteds, and we go over to here. Now we have the predicted values, and we go here to calories, and we type 600, and there's the answer. Should be the same answer we're getting right here, and it's even more decimals. So it actually solves it for you when you save the predicted. So that's really the power of software right there, is I should know how to plug it into the equation, which I did going back to the Word document. I plugged 600 into the equation and then just mathematically solved it. But then I do know that the software will also get the answer for me. So we're just showing multiple solves to the same question, but we should understand plug in your value of x to get the predicted fat. So I'm going to ask an additional question right here because it's very important we review all the topics. Let's ask a big question right here for 10,000 points. Hopefully, if you're not in my class, I don't know how I give you the points. But let's ask this question right here. And the question is going to be, so we should get 100 on this. Did we get 100? 100, I like it. Let's say, for instance, that this 600 calorie burger has 30 grams of fat. This 600 calorie burger actually has 30 grams of fat. So what I've just told you is that we figured out that the predicted value for it, this y hat, or we'll call it y hat for the moment, is 34.8 after plugging in an x value of 600 into the equation, and I told you that it has actually 30 grams of fat. What is the burger's residual? For 10,000 points for anyone in my class, what is the burger's residual? What is the burger's residual? We predicted it would have 34.8 from the equation. When we solved the equation, we predicted 34.8 grams of fat. It actually, like we order and like, oh, this actually has 30 grams of fat. So that's how much it actually has. Like its real world fat content is 30, even though we predicted 34.8. So what is its residual? So I'm going to write out the equation down here if you remember. And I know Julio put in the chat yesterday, and I love it because we remember RAP equals, close. Lindsay, you're so close. You're still getting the points, though, for the first answering. You're so close, unless my brain has reversed it. So very close. What is the exact answer? Yes. That's what we need to make sure there, because it's residual equals the actual, which is y minus the predicted value. So residual is 30 minus 34.8. Notice I just have the same notation up here for y hat as I do down here. And so it's 30. So I'll just fill it in so everyone can see. Sometimes people have said, wait, what's the equation? And so it's negative 4.8 equals 30 minus 34.8. And just one way to do this when you're doing it, 10,000 points to Julio also, great job. Another way of checking that you have this down is to every time you get something, put it in notation. If you follow the notation, usually you'll do it correctly. It's easy to reverse it, and usually we think of residual as just the difference, but this burger was predicted to have more fat than it should. So when you look at it, here's your line, here's the burger, and the residual is negative because it had a higher prediction. So when you explain what the residual means, this burger was predicted to have more fat than it actually did. The prediction, which is the line, is above where the actual point is. So the difference is negative 4.8. It doesn't always need to be negative. We can do a counterexample now. This burger was predicted to have the same amount, but actually has 40 grams of fat. So there's another burger that has 40 grams of fat. What is its residual? Another burger has 40 grams of fat. What is its residual? Another burger has 40 grams of fat. What is its residual? Great job. And thank you to everyone in the chat. Great talk in the chat today. Julio, you are, when you, I don't that's amazing. You're doing such, you guys are awesome. I love teaching this class. I love seeing the answers. I love people getting them right. And right on. Abby, 10,000 right there. Great job. So understanding that this point right here, let's highlight it. We'll make it green. This green point has a positive residual. This red point has a negative residual. Nothing wrong with that. The green point is just 5.2 above. And then I don't know what I did or not. I don't even know. But that's got it. Does that make more sense to this question? I know we maybe have some other My Pearson questions. What is everyone thinking right now? What else do we have? What other My Pearson questions? Let's hop into another My Pearson one. Knock it out of the park. Do some review. If you can't tell, obviously I just solved a My Pearson question. Can you explain Chapter 7 quiz problem number 4? It's on creating a linear model for the relationship between cars, age, and price. Yep, cool. And the quizzes switch around, so thank you very much. Help with question 5 on the clustering homework, please. Yes. I'll put that at the end of the video. How's that sound right there, Mason? I'll put that at the end of the video. And is that making dendrograms? Is that I'm trying to think. I'll put that at the end of the video. So the mortality question. Oh wait, that's a totally different one. What is question 5? I think I was doing that one earlier. Is that using dendrograms or k-means? And then we'll do the mortality one next. We have the car age and mortality. So let me make sure. I think we passed car age. Okay. Where's car? I love that question. That question. Does no one want to do that question? It's so much fun. Okay, here we go. Is this the one you were looking at right here, Abby? Is this this one? Yes. We got some good responses for this question right here. Okay. So with this question right here, once again, we're going to go to jump. A very important thing for the test is know how to read jump output. If you missed it earlier, I was explaining in the video how to read jump output and making sense of what's in here. You've got your equation right here. I'm hovering over the equation. You've got your B0 right here, your B1, and check those out. You've got the significance of the line. It's a bit different. There is another car age one. How about we'll do this one, and then I think there's another car age one, and so we'll do that one next. How's that sound, Abby? Because I think Josh wants us to do this one. So we'll do both of them. So remind me, we're going to do this one, the other car age, and then we're going to do the mortality with the calcium. So we're going to do all three of those. We got that coming right up here. So let's hop in because we had some great response to this one. This one's another jump one. There's other ways you can use the calculator, many ways to do this one. We're going to copy to clipboard. We're going to hit Command or Control C to copy it to jump. Once again, knowing how to read jump output is very important for this test, and I'm going to focus in on a few things on this one more importantly. Now what I'm going to do is I'm going to go to File and New Data Table. Now I can't stress this enough. When you're inside of here, you must use paste with column names if there are column names. A lot of times there are column names, so we're going to paste with column names. You should see blue. If you don't see blue, start a new sheet, paste with column names. Don't click inside the sheet. Follow what I did. New sheet, edit, paste with column names. Don't click anywhere. A lot of people will click inside of it, like, no, and they're like, what? That's what, you know. And so that's how we do it right here. Okay, let's go to Analyze, and then let's go to Fit Y by X. And we're going to predict, what does it sound better? Do we want to predict the age of a car or the price of a car? Well, to double check the question, it says here, it gives us R squared, and I think this one's one of the easier ones to do. But we're predicting the price of a car from the age of a car. So this one is the quicker one, and we'll do it. We don't have to do this one in jump. I'm going to focus in on some stuff. So price would go into Y, and age would go into X. When you do this, you want to ask, does age explain the price of a car? Does age explain, 10,000 points I wrote there. During the exam, how will questions differ since we won't have the software? You will often get this output. So here's some good example of exam questions, and I've often used this tons of time. I'm closing this output right here just to minimize what we're looking at. So let me do this. We're going to screenshot it. And you know what? We don't really need this. Oh, we do need that. I thought it'd let me close that. What a bummer. Let me make this super small. That's good. We're not going to use that for the moment. And we're going to take this. Okay. These are, I think most people can understand the graphics. A lot of people have a harder time understanding this output screen right here. So we're going to bring this over to Word. We're going to talk about it real quick. Okay. Once again, know what you have in your output. The most important things in your output are right here. You have your R squared, you have your B0, you have your B1, and you have your significance of the model. Those are the 4 things in the output you should know. We have right here, once again, the R squared, and my class should know R squared is not correlation. You do, how do we find the correlation Q1? Oh, I think I'll do it right next. The first question, and I'll show you right here. R squared is not R, exactly. But you know what the thing is you can square root R squared to get R. Now, the interpretations are different. Even though R squared is not R, they're 2 different concepts. You can square root R squared to get R. So we've already got an answer to the first question here, where we can come back here and it wants the correlation. Now, here's where people make a mistake. They take this value right here of 0.892 and they square root it. So let's go ahead and square root it. And they get the following. And this would round to 0.944. And they put that in. Now you're going to get this wrong, though. We have to go back and look at the jump output to see why this would be wrong. Why is 0.944 the wrong answer? Oh my gosh, I broke it. Why is 0.944 the wrong answer? Why is 0.944 the wrong answer? Negative, you're right. It has to be negative. R squared does not have positive or negative on it. So when you square root R squared, many people have been like, how do you know it's negative? The slope right here is negative and the line is negative. So exactly, nice job. Whenever you square root it, just be like, pause. I have literally seen people make 99s on the test. I've seen 99s and they're like, and they'll show me, they'll do it in their calculator. I've had people be like, Brian, this is the answer. Look, I've got a misgrade here. I got 100. And I'm like, it's negative. And they're like, oh no. And they know it. They know it when they see it. It's a very common mistake. Lots of 99s. I've seen it multiple times. So this needs to be negative right here. So we know it's negative because of the slope, and I feel so bad. They've been like so sure. Explaining the meaning of R squared. Don't look at my Pearson's answers. Don't let them trick you. Every time we do R squared, we need to say blank percent. I'll take a 99. Take the 100 even more though. So, but yeah, 99s are great. I know it hurts. The 99, you're like, oh, I almost got it. So close. When we do the R squared right here, we need to remember how to interpret it. I've actually got it in here. Please note how I'm going to interpret R squared. Watch this right here. I want you, when you read R squared, to do the following. Watch as I highlight. 89.19% of the variation in advertised price is explained by the age of a car. So what you just heard me say is blank percent of the variation in Y is explained by the variation in X. Hopefully I said variation a second time there. 89.19% of the variation in advertised price is explained by the variation in variation in age. 89.19% of the variation in advertised price is explained by the variation in age. Without the variables in, which you need to put the variables in on a test, it would be blank percent of the variation in Y is explained by the variation in X. So once again, you can rewind. Blank percent of the variation in Y is explained by the variation in X. With the context, 89.19% of the variation in advertised price is explained by the variation in age. So we go back over to here and we see if any of those answers possibly make sense. Exactly, typing in the chat, another 1,000 points right there. Advertised price accounts for, age accounts for 89.19. And you notice they changed it on us, but if age is accounting for this, age is explaining it. So if age is accounting for, that means age is explaining. Or 89.2% of the variation in price is accounted for by age, is explained by age. What is doing the explaining here? It's age. Why doesn't the model explain 100%? This has been one of the questions that I think they changed because I actually had problems with it. Let's see what the right answer is this year. I think it's going to be D. It's impossible for real-world data to be perfect. Data can be perfect. There's not enough data points. If you had 2 data points, you could get it. I think, is it D? Everyone's saying D in the chat. Different dealers ask different prices. That's A is technically kind of a right answer. This would not be a test question, and we got 100. That's not a good test question. A lot of times with my Pearson question, I'll love like most of the questions. Like I think the first 2 parts of that are great. Understanding what the slope and the intercept are is excellent. And then what I want to do for the last part of this question, we got 2 more to come after this, at least 2 more, is I want to talk about this. I want to go here and I want us to interpret the slope and the intercept. And since maybe it's not in the videos, I'm going to go and do the following right now, which my class should know pretty well by now. And so if you're watching this from another class, have this down. When you interpret the slope, it is going to be for each 1 unit increase in X, we expect Y to increase/decrease by B1. The intercept is when X is equal to 0, we expect Y to equal B to equal B0. That's the 0 right there. And then can we extend the time until maybe? I think we can. I think we will. I think I had another student who's working today and he was like, could we? I think we can. Just this is a one-time thing, just the test coming up. I don't want everyone to be like, Brian will extend the assignments every time, because then all of a sudden people stop doing them. It's like, it's a one-time thing. And then everyone's like, he'll extend it. No, so I hopefully, so Sydney, let's do that. And then make use of the videos. I'm always here on the Wednesdays trying to help out doing the video reviews. So thank you for everyone who comes by and everyone who watches these videos. Some people work during time, so it's all right. People say, Brian, I have to work. So I try to put video help out there so you can check these out. So this is blank percent of the variation in Y is explained by the variation in X. And some people, I will say this for the slope, like to say for each 1 unit increase in X, we expect Y to increase or decrease by B1 on average. The thing is, and for anyone watching this, the reason I don't care for the on average part is because when you go to BS 320, we have a very specific way of talking about the slope that is super accurate. It's 2 observations that differ by 1 unit of X are expected to differ by blank units of Y on average, where the higher X, one with the higher X is expected to have the higher Y, but it's not, it doesn't sound like change. So we have a very specific way later on that's a little more complicated, but very specific and very kind of exact. So I've never found this to be exact, so I've never really cared about the on average part. I've been like, whatever, this works. Sorry. No interpretation is perfect. And, I think this interpretation of the slope communicates everything we need to get across until we get super specific on what are we actually talking about. And that's something we cover in the regression class, because this makes it sound a little bit like cause and effect. Just tiny rant on this real quick. If you look at an equation like height and weight, and I want to talk about this briefly here, and let's do an interpretation. We're going to interpret an equation where we have height being predicted right here. So this is going to be predicted from your weight. So I want to highlight the interpretation we use in 201. The interpretation in 201 would say, for each 1 pound increase, we would expect someone's height to increase by 0.15 inches. For each 1 pound increase, we would expect someone's height to increase by 0.15 inches. But think about this. If you want to be taller, doesn't this equation kind of make it sound like you could just gain weight and get taller? Now, we do know that people who weigh more are generally taller. That doesn't mean if you weigh more, you are taller. But the 201 interpretation of this, which says, for each 1 pound increase, we expect your height, or we would predict your height, would increase by 0.15. That doesn't sound perfect. And then we add on the on average, and it really doesn't help it. But here is, and so whatever you do, if you're in 201, close your ears because this is 320. In 320, we get more exact, and Julio gets another 1,000 points in the chat. Perfect. In 320, we get very specific, and we say 2 individuals who differ by 1 pound are expected to differ in their height by 0.15 inches, where the individual who weighs more is expected to be taller. So that's the 320 interpretation, which is a little bit longer, a little more complicated. That's why we save it for we're going to get specific and do a class just on regression. So 2 individuals who differ by their weight in 1 pound are expected to differ in their height by 0.15 inches, where the individual who weighs more is expected to be taller. So we just say, well, generally people who weigh more are expected to be taller. That doesn't mean they are. It's what we expect according to the predictions from the model. I have my ringer on. So I always want to bring people live on these and be like, hey, you're live on the internet, but you never know what's going to happen if you do that. So with this in mind right here, I should tell the person, be like, I'm live on YouTube, go check it out. And you could just ask questions in the chat. It was my brother. So yeah, is it? I should have hawked and said, hey, Darren, you ready? Wait, watch this, you ready? We're going to do this. Hey, Darren. I'm live on the internet. You want to say hey to the internet? You're live on a YouTube video right now. Do you want to say hey to the internet? Wait. Here we go. You're live to the internet right now.
Hello, internet.
I'll let you go. I'll talk to you later. Okay, man.
Goodbye.
Say hey to him in the chat right there. I was like, he'll be good. He'll be good on the internet. So. I'll show this to him sometime. I'll be like, yeah, that's when you're on the internet. Okay, so okay, we're gonna get back serious here. I'll tell him you said hey everyone in the chat. So gotta do some fun things, right? So okay, so I think we got 100 on this one. And then Nacho, we got you coming up here. I'm working on chapter 7 homework. I'm caught on part D, the actual formula. Which one? I think Abby wants the other price and car one. If you can tell me more about the problem, and then we have the calcium one. I'm gonna find the other car and price one. Since these don't always have the same order. Wait, is this Abby? This is the one right here, right? Yeah. So yeah, Lindsay, I'll do that next after this one. Abby, is this the one you're working on? So yes, this is it. Okay, cool. And then we'll do college applications coming up here. So we've got this one, calcium, college applications, and then we'll do GPA score and everything. Thank you for hanging out. And those are going to be really ones, the GPA and SAT score ones. And all the homework will be open until test day. That is correct. Get those hundreds in. So let's go right here. Let's copy this to the clipboard. You know what we're going to do. We're going to hit Control-C. We're going to bring this right here. We're going to hit done. And then we're going to bring this data right over here. We're going to hit Control-N. Control-N or Command-N opens a new tab or a new whatever you're in. You can do the same thing by going to File, New Data Table. And we just have our new data table. What are we going to do? We're going to paste with column names. We're going to paste with those column names. We've got the data inside of here. We're going to go to fit Y by X. We're going to predict the price of a car from the age, which means age needs to go into that X variable. Now we've got our equation. Looks like a negative slope to the line, and boom, we got it. So once again, rewind the video. We've done this a few times now, so I did a little bit quicker, a little more quickly. and more quicker. Grammar. But now we have what we need to solve this problem. We have the equation of the line. Once again, remember, we've been highlighting each time that this is the intercept. That's where it hits up there. It's even if your graphic looks like this, do not be tricked. I had a really good student say to me that the intercept is 1300. It's just because the graphic did not go to 0. The intercept is always, oh, we've kind of made it all crazy now. The intercept is always this number right here, which is the same number down here for the estimate of the intercept. The slope is always the number that is connected to the x variable. That's your x variable right there. And there's the coefficient of the slope, or the estimate of the slope. And you'll see right here it's the same number down here, and you see the slope is negative. So let's hop back into our question, and we're going to need the output on the screen. Oh, man. So it wants to the nearest integer 17776, rounds down. And then we have 830. And explain the meaning of the slope of the line. So think about this right here. Think about the slope of the line. With the slope of the line right here, what do we have going on? The slope of the line is going to be, can anyone do it in the chat? This is really good practice. I try to highlight the things you should really know for the test. Things like interpret the slope. Think about for each 1 unit increase in x, we expect y to, and then don't say increase or decrease, but say one of them. And hint, it's negative slope. So for each 1 unit increase in x, we expect y to then do something. For each 1 unit increase in x, we expect y to do something by this much value. For each 1 unit increase in x, we expect it to decrease. And does anyone know the full interpretation? I'll say it here in a second so we can complete the question. But for each 1 unit increase, let me do the whole thing. For each additional year of age on a car, we expect the price of the advertised price of the car to decrease by this amount. And just think, this mathematically, when you put in different values of age right here, it's actually going to be making it go smaller, because as we do this right here, bingo. And then you can throw in the on average you want, especially if another class might throw in that on average. Graders sometimes look for that. If your teacher has used on average, use on average. I've just never been a big fan of it. So once again, because we teach it at a higher level, and I'm like, it's not the end of the world. And so right here, you can see every time I do this, it's going to make the line go down further, because every additional year decreases the price of the advertised price of a car by this amount. So we've got our equation, we've got our meaning. The slope indicates that for each additional year of age on the car, so the slope indicates that every 1 year increase in age decreases the price of cars in this model by this. And once again, if we were doing 320, we would say 2 cars that differ in their age by 1 year are expected to differ in their price by $830. Ooh, did someone notice? I forgot the negative on the age. That is a common mistake. Do not forget that. That's a common mistake right there. You just think that the equation has the negative for you, and then you're like, oh, I guess it doesn't. But that should do that. Let's interpret what the y-intercept means. And remember, let's show what we have written for it. The y-intercept is when x is equal to 0, we expect y to equal b0. Hey, Spencer, you're so awesome. We're going to do a little question 5 coming up here. So you guys in the chat are awesome. So what we have right here is when x is equal to 0, we expect y to equal to b0 for each additional year in car. I'll do the slope again. For each additional year of age on the car, we expect the advertised price to decrease by $830. Now, what is the intercept? The intercept is b0, and so this is b0. Kind of always have your notes out and plug and chug. Put it right in there. When x is equal to 0, when age is equal to 0, we expect y. We expect advertised price to equal b0, to equal 17,776. What is a car that has 0 years of age? A car with 0 years of age is a brand new car. I feel like I'm on a game show. A brand new car. That's not. How do they say it? They're like, and you win a brand new car. You got to extend out that right there. Speaking of, my brother was on The Price is Right. Won a lot of great stuff. Won a grand piano. He won The Price is Right, Showcase Showdown and all, with Bob Barker, nonetheless. Back in the day, like 15 years ago. Oh my gosh. Someone in the chat's like, okay, boomer. So it's getting old here. So explain the meaning of the y-intercept. So when x is equal to 0, where's the key? Oh wait, Bob Barker says, oh, where's, I don't get it. I'm so confused. Explain the meaning of the y-intercept. Select the correct choice. The y-intercept means for a new car, because remember we said when the age of a car is equal to 0, we expect the car to be this much. And so we just take this answer here, 17776, and we put it into here. And we're selling an 8-year-old car. So when we're selling an 8-year-old car, we need to go back up here to the model and input the value into the model. It is having us round it to like one integer, which is a really heavy round on this. So I'm gonna see if it gives me the right answer using this, because that's a big round. So I'm copying my answer so I can take this number and subtract it. And all I did, please know what I did. I plugged 8 into age, and then I multiplied, and then I subtracted off this number. So it makes sense that it should go down. And what I would do, I'll show you what I would do if I was doing the test. We're gonna see if we get all the answers correct. Oh, there's more? There's more? Whoa, there's more. Okay. What I would do if I was taking the test is I'd immediately look at my graphic, and I'd look at the 8-year-old car. And I'd say, okay, if I'm buying an 8-year-old car, where is this line at? And if you look at this line right here, is that about 1100? Because when I solved the math solved out to 11,000. So does that line hit there? Because an 8-year-old car, do you see how I'm dropping a line down to it? And it does look to hit at about 11,000. So the line can help you check your mathematics, because this line is the prediction line. And it'll actually show you that that car was advertised that car has a negative residual because it's below the line. So double check, use the graphic to help you out to be like, okay, does that make sense? Is that, if I make that prediction, does that line up? Yep, it does. My new car, I don't want to joke and say that's what the Kahoot winner gets. If we get some massive funding, if Elon Musk comes in and donates a Tesla, I mean, that'd be amazing. Like, imagine the news story, like students win Tesla for winning Kahoot. So he's more than happy to donate a Tesla. I mean, the taxes on that are going to be crazy. Maybe you could do some prize money also, but I'm more than, as long as we can clear out the university, we could do his sponsorship, and we could give away a new Tesla. We would need sponsorship for that. I don't have the money to drop on that, but that'd be fun. Could you? Oh my gosh, people be going crazy in the Kahoot. It'd be nuts. So you have a chance to buy one of 2 new cars. They are about the same age and appear to be in equally good condition. So it should say they're identical cars. It should be like, they are literally identical cars being sold by 2 people. Would you rather buy the one with a positive residual or a negative residual? So let's go and look at our graphic again and make sure we know what a positive and negative residual is. So when you think about the negative residual space, it's down here. That's a negative residual space. Anything below the line is a negative residual. We can do one better. We can copy the graphic and we can draw on it. We always want to draw on these graphics. So positive and negative residuals work the following way. Let's hop into our world right here. And let's go take a look at this right here. And what do we have? We have the negative residual space is down here. So here's your negative residual space. Here's your positive residual space. So imagine you could buy a car, and the car is right here, or the car is all the way down here. This is car A. This is car B. Which car would you like to buy? The car with the negative residual or the positive residual, and why? So we've just made a virtual example of it to help our minds see what's going on right here. Always do visualizations. It helps people understand. We have the choice between A or B. B has a negative residual because it's below the line. A has a positive residual because it's above the line. And the negative, definitely. Why? The negative car costs $9,000. Both cars, if you do a prediction for both cars, we're going space pen here. Both cars are predicted to be about $13,500. So both cars have about $13,500 prediction. But then, because the price will be lower. Yep. And the question tries to make it clear to you that, does SpacePen do? Whoa, I thought it worked a different way. I'm learning more about SpacePen. How do you get jump to display B0, B1? B0 and B1 are found in jump in 2 spots. In your jump output, B0 and B1, B0 will be right here, and B1 will be right here. Also, they're down here at the bottom, we should know. B0 is the estimate of the intercept, and B1 is the coefficient or the estimate of age, which is the x variable. Carson, does that help out right there? Or are you not to this step where you have the jump output? And I'll review right here since you asked. If you have your data copied into jump, make sure, we're going to do it again, open a new jump spreadsheet, edit, paste with column names. Once you, we're trying to paste an image. Go and take your data. You got it. Awesome. Well, okay, we're good. That's where it was at. Carson knows now. We've done it a few times in the video, so I'm going to continue on. The car with a negative residual would be better because its actual price is below the predicted price. I believe that's correct. The car with the negative residual is better because its actual price is above. No, its actual price is lower. It's saying you have two virtually identical cars that you've tested. Your mechanics looked at them. It should be like, for all intents and purposes, these cars are identical. And so you want to buy the negative residual because it's predicted to be more than it is. If it's a negative residual, it's below, which means its prediction from the line is above. So you'd be like, this car was predicted to be way more. Now you might say, something seems odd about that, but we'll pretend that it's just the same value car that you're finding for a better price. You see a for sale sign on a 15-year-old car. Now we've done this a few times. We have to remember that when we have our model, did I delete my model? Let's make sure I have the right model right here, which I don't think I do. This is not the right model, so I'm going to close that one so I don't get confused because I could get something wrong by having too much open. It's this one right here. This is the correct model we're using. We're going to just decrease screen size right here. What you can do, this is a trick when you're using jump. You got it for cheaper, exactly. You can go right here, you can click the arrow, and you can go to Save Predicteds. Save Predicteds. And with Save Predicteds, we're going to go inside of here, and we're going to look at that. We got Save Predicteds right here. Now, let's say it asks for a 9-year-old car. You can go here and type 9, and it'll do the prediction for you. Now, all this is doing, I want to make this very clear what this is doing because this is actually something you should be able to do on a test. All this is doing is going to the equation, and inside of age, I'm pointing to age, you can't see me highlighting, I wish I could highlight on this, but inside of age, you would see that age would have the value of whatever you're predicting in there. So you just plug in like 8 for age, or 9 for age, or 10 for age, whatever age is, and then you make a prediction with it. So this is a 15-year-old car, so actually we don't have that data point. So I'm going to go back to my jump worksheet. 2 screens can get very disorienting. And let's go right here and put in a 15-year-old in the right jump worksheet. You have to save the predicteds from your model. I just did that a moment ago in the background. Yes, we're going to do a regression calculator next. So let's look at that next, Alexandria. Awesome. So this is the prediction of the car right here. We're going to copy paste that answer because copy paste is awesome. And then it is predicted to be this much right here and to the nearest dollar. And we have one of our best concepts right here that when we do things that are outside the bounds of the model, we are extrapolating. So let's make sure we know the concept of extrapolation. Extrapolation occurs when you make predictions outside the X bounds of the model. So in technicality, the prediction we just made is an extrapolation of this model. What do I mean by extrapolation? I mean above 10 is extrapolating the model. Technically, do we have any 0-year-old cars? So technically down here is also an extrapolation because we don't have data below this. Why do I say extrapolation? Extrapolation is when you leave the X bounds of the model. The X bounds of the model is an extrapolation. So you'll actually get a negative number right here, which is impossible because you're extrapolating from the model, and the model is just really not meant to predict. It doesn't say extrapolation there. I wish it did. And oh no, what did we round incorrectly? Oh no, did I answer everything? Where's the one I was worried about if we were rounding? So we have one thing off. Where did I mistype it? You guys have to help me out. Decreases. Okay, that should be right. That's right. That's right. Explain the meaning of the y-intercept. The y-intercept indicates that means that a new car. It means that a car of this model. Okay, that's correct. If you want to sell an 8-year-old car. Now I wonder. Let me try the 8-year-old car, and let me put it into jump. Because I wonder if it's mad about those decimal places. So the 8-year-old car would sell for this. Let me grab that number. Was that the issue? Because everything's theoretically correct. Round to the nearest dollar. Now here's the thing. Jump is predicting the same there. I wonder if anyone in the chat sees where my error is. One error we don't want. Oh, don't want to do that. Put it in our. Actually, I might. You have two choices. The car with the negative residual is better because its actual price is below the predicted. So it has to be this last one. You see a for sale sign on a 15. Oh. Wow. I missed the last part of it. This is it. I'm 100% certain. Can anyone tell me the answer to this? So it should be. I got it. Can anyone tell me the answer to this now? This is the issue. I just read it too quick. I should have realized they asked us to make a prediction here. Now they're asking us for the residual. I just read the first part of it. It was like, you know, a 15-year-old car. And I do this all the time. Students do this all the time. You see part of a question. You saw part of it. It's my fault. So someone's be like, he didn't know the answer, but this is the predicted right here, and we get the actual. So we know the actual price of the car. The actual price of the car is $4,700. The prediction is $5,326. So let's do a little mental math right here. If it wants us to round to the nearest dollar, as long as everything's right from the past, we should do negative 626. Not that. I'll explain how I got that right here. I should do it. I'm doing it in my head. There we go. Got it in my head. Good. So what it was, let's look at the jump to show what happened here, is that we predicted this. Now, what we have right here is the actual price of the car is $4,600 right there. It's not a $46,000 car. So that's the actual price of the car, and this is the predicted price. And I wonder if jump will actually solve the residual for us of that new one we put in if we go here to save residuals. And it didn't have the math for that, but the answer is it didn't want to use what we had for it. The answer for this one is going to be, I wonder if it's made about those commas. It would be actual 4600 minus predicted, and the predicted is 5325.5851602. Does that make sense? What in the world is going on? Wow. That's why you do it in your head, because 600 minus 53525.585. This computer's haunted. Wait a minute. Oh, did I? Oh, you know why? Wow. I bet you it's that, because I did it in my head, and then... yeah, it is that. I was like, how would I solve it in my head? Wow. It's hard using two-screen here. What is going on? It's called Brian should eat more lunch. It's called you need more brain fuel. So there we go. It's called just eating the candy in your office is I brought some lunch, but yeah, it's getting late in the day and eating at 11 now. Yeah. Anyways. Okay, wait. Okay, let me explain. You ready? I wish we should cut that part of the video. What it is, let me show you by writing it out. Okay, we were given in this problem that y is equal to 4,700 right there. We were given x is equal to 15. From x, when it was given to 15, we got y hat equals to, this is when we made the prediction, we got a predicted value, which is the predicted price of the car of 5325, and we'll say 5326. So we got a predicted of 5326. So now we can do the residual formula. As everyone knows, residual equals actual minus predicted. So that's E equals Y minus Y hat. So this is where I took and solved the equation. And now we'll actually do it in the calculator with the rounded version. We're going to do the actual of $4,700 minus the predicted of 5326. And look at that. We get the answer right there, negative 626. Does that make more sense right there, Julio? That we have the actual price of the car, which is the Y value. That's the actual price. We have the X. We use this to find the predicted. We plugged X into the equation. And then the Y hat is the predicted price of the car. Then we use the formula that the residual is equal to the actual minus predicted to get the residual. So just make sure to keep your numbers straight. Very easy to mix something up. Very easy to not read the whole problem. So you get the predicted price from jump. You can do it also by doing the following. If you want to do it by hand, you don't have to use jump, and you should know this for the test. If you notice right here, we have the equation. So I'm going to do this right here. I'm going to put this over here. And let me see. I wonder... It's going to lose it. Ooh, squeaky noise. We want to go y, let's write it in context. So predicted price is equal to, I think it was 17,776 minus 830 age. And this was a 15-year-old car. So what you would do right here is you would plug into this 15. And from this, you would get that predicted price is equal to, wow, it's bad when I'm starting to memorize this question, 5326. And so this is because X was equal to 15, which is age. So we'll call that age since it is the age of the car. So age of the car was equal to 15 years. And then price of the car, the actual price, so this is the actual price, was equal to $4,700. So that is kind of the notation for this problem. Know your notation. Easy to make mistakes, easy to overlook something. We all do it, so don't worry. I just wanted to show you guys you can make mistakes on these. It happens. But that question wants the residual of it, which when we do the residual, it's going to be the difference between these. But remember, it's the actual minus the predicted. So we're doing actual minus predicted. So the residual, we'll write that right here. The final answer we're solving for is E. So that's the residual in notation, is the actual of $4,700 minus the predicted of 5,326. And that will get you equal to, we got just enough room here, to negative 626. And E stands for residual. We've got our actual price of the car, our predicted price of the car, and there's the residual. Does that make more sense to everybody? That's how you do it by hand. You should know how to do it by hand. You should know the formulas. Jump can just make life easier for solving some questions, but know your formulas, know what it means. This formula right up here again is my y hat equals B0 plus B1 X. And so that right there, nice job. Good review, good practice right here. We had a question about doing the problems with the solver, and I've actually advanced the solver and made it even better. So let me pull up the solver, and we've also got the calcium question. So awesome stuff right here. And this is really good review of regression. Okay, let's pull down the new regression solver. Regression solver 2.0 Pro, or Pro 2.0. I like calling things crazy names. Okay, so here we are. We're in our Regression Solver Pro 2.0. So what I did in the Regression Solver, one person had a weird issue. Please tell me if there's any weird issues with this. I've only seen it with one person so far, and I couldn't fix it, but everyone else it was working for, so yay. Sorry. Please tell me if there's issues, though. It can be due to errors that we make, but you only enter stuff into the yellow fields. So if you want to do a regression right here, you can do a regression by entering values into here. Probably the best way is to just manually enter them by typing them in. Make sure your X is the X variable. Make sure your Y is the Y variable. R does not jump. My Pearson does not always put them in the same spot. It worked for you, good, awesome. And just make sure the X is the X variable, because sometimes when you copy paste, the X will go into the other spot. So make sure your X is where the X should be and your Y is where the Y should be. So just make sure. Because if you put it in the wrong spot, or if you put words up here like this, that'll cause problems. These need to be the numbers. Probably just type it in is the best way. Just type in your Y data, type in your X data, and you're good, and this will solve for the equations there. In other questions, you are given this right here. These are two separate questions. Like the lower one is when you're given the data, and the top one here is when you're given the summary statistics. Like it might say a correlation of 0.25, it might say a standard deviation of 15, standard deviation here of 12, and then 50 and 60. And it should work. The person was not having the numbers display up there, and we tried re-downloading it, and I don't know why it didn't work. Down here, you can type in a value into either one, and it'll make a prediction for you when you input a value of X. So when it says make a prediction for a 15-year-old car, which is not the same thing, I could put this in right here and it would make a prediction, and this is the predicted value right here. So hopefully this helps people with these assignments, because we're not about, what we're not focusing on is just working math equations by hand. Yes, the high school and the test scores. Let's do that, Carson. You had a rounding issue. If you're one of mine, contact me. I always give you guys the points back on rounding issues. And no, we haven't done it yet, Carson, so let's do that question. Thank you, Carson, for hopping back in. And let's do the S8. Is it this one? Did we find it? We haven't done this one yet, so perfect. So hopefully I enter in all the numbers correctly. I think this is it. This right here, you'll know you're using the regression solver, which you could do it by hand. Not the end of the world if you do it by hand, but why not use tools when they're available? So if you notice, it says the mean SAT score is 1212, and the standard deviation of it was 122. The mean of GPA was 2.66, and the standard deviation was 0.54. The correlation is 0.44. Correlation is R, and is this the one that asks what the correlation is? Oh, that's such an easy question. I like it when it says, what's the correlation? It's correlation. So know your notation. Correlation is R, and that's not R squared. If we square it, we get R squared, which is the percent of variation Y explained by the variation X. So write the equation. We need to go to our regression solver. So we're going to do a little dual screen right here. We're going to go left screen, and then we're going to go right screen over here and dual screen this. So let's get this nice and centered on here so we can see what's going on. We're going to use the top solver, and you guys in the chat tell me if I make an error here. So the important thing to know is, one, correlation is easy to know which one it goes for. The one with the verbal scores and the math scores, we'll do that one next right here. We got the calcium one, we got the verbal scores, we got all these. Great questions. So let's hop right here and type in this. Now we have to know which is the Y variable, which is the X variable. Look at the equation itself. Do you see where it says over here? Let's go to it. GPA. Since GPA is in this position, GPA is the Y variable. That is in the Y position in the equation. So when we go right here, we're going to have to understand that anytime it asks for Y, like standard deviation, that is standard deviation of GPA, which is 0.54. Let's go ahead and get the standard deviation of X, which is the standard deviation of score. And the standard deviation of score is 122. And now we need for X, which is the mean of score. Make sure I don't get these reversed. I wrote this, and yet I can still reverse it. And now we need the mean of Y, which is 2.66. And there we are. We've got everything in here right now. Make sure everything's entered in correct. Make sure everything is entered in the correct way. So it is tricky right here. Just make sure this one wants 5 decimal places. So I think this is set up right now to exactly 5, so we should be good. 5 decimals, that is craziness. I guess because that one has such small remainder on it, it makes sense to do 5 decimals because it's really being carried out far. So actually we're done with the solver for now. Awesome. We got what we need. Yeah, we can do the mortality one next. Can we also do the question about hardness and water? Yep, we'll do the mortality one next right here. So we'll do mortality next. How's that sound? Mortality next. So explain what the y-intercept of it represents. The y-intercept represents for individuals who have a 0 score on, oh no. The y-intercept represents people who had a 0 score on the SAT. So when SAT score is equal to 0, we expect someone's GPA to be equal to 0.299. So interesting. I think we might head over to the mortality one. Does this make sense on this one right here? I think people are asking about other SAT ones, so I might jump over to the mortality one. The one with the math scores and the verbal scores. Yep, we'll do that one here too. Let's hop over to mortality. I don't want to do every single question. We're gonna cap it at. So we did this one, got you started on it. Make sure you know how to do your interpretations. Kind of want to get people over this jump kind of bump where we have to use jump or we have to use the solver. So we just showed some of using the solver right there. And so let's. Am I out of it? Why did it do that? Oh, that was easy. Yes. Hardness and water question. Hardness and water question. But that question is so fun. I like that one. Here it is right here. We've got the hardness and water question. So with this question right here, we're looking at a plot. Yes. Oh, Lindsay wanted me to talk about the 4 conditions. So the 4 conditions of regression. We're going to just talk about this briefly right here, then we're going to hop into the hardness and water. Thank you everyone for understanding. We're just kind of jumping around and staying on one topic for a moment, and let's do the 4 conditions. So I like to say QQ straight enough, no outliers, plot does not thicken. But what do I mean by that? Well, the first condition, if you're writing it out fully, is quantitative variables. How do we check this condition? To check the quantitative variables condition, we have y and we have x, and they both need to be quantitative. Now, I accept QQ because that means 2 quantitative variables. You need to explain in your answer what it means. Both y and x are quantitative variables. This one is kind of the gateway to doing regression, because if you don't have quantitative variables, you can't do regression. You're not doing the regression we do in our class. There are other things like, I won't say it, logistic. But we're not doing the regression we're doing right now with two quantitative variables. The next one is straight enough. Straight enough. So when you're talking about what is being straight enough, the condition does not say perfectly straight. It says straight enough. So we're going to draw 3 examples right here. First example is like what we'd love to see. That's great. And it doesn't have to be as tight as that. That's just the strength of it. It could be like this. The reason this is good is because a line would go through the middle of the data and does not need to bend. Now, straight enough means, yes, there could be a little like bend. We're going to add in a little bend right there where it kind of, little bend. I put a little bend. That's straight enough. Yeah, okay, a line, it's kind of, there's a bend. Truthfully, I don't like that bend. It's a little bend. It's straight enough. The hard part is like, we'll try to make it obvious on the test, like this last example here, where it's not straight enough, where this last example is a parabola or some sort of exponential growth function. And now if you were to fit a line through this, the line might look like that, and that is nowhere near straight enough. So in truth, this first one is definitely good. This one is like, don't worry, we try to make it fairly obvious. And this last one is really bad. So straight enough means a straight line well approximates the relationship between the two variables. Question number 3, or part number 3, QQ straight enough, no outliers means what it says. There are no outliers. Now, outliers has an I. Sure, wherever it goes. Outliers, no outliers. With no outliers, we have some data points like this right here, and oh, look, there are no outliers. It's also straight enough, and it doesn't have to be super strong. It could be weaker, but this is a straight enough relationship, so that is good. If you see something right here, you could get a plot like this, and you could have an extreme outlier over here, and so now that would fail the no outliers condition. So this is good, and this is bad. Now, this right here, these are the 3 conditions for correlation. So we have here correlation conditions. So those are the 3 conditions for correlation. But with regression, we have a 4th condition. So with regression, we have plot does, and I like to say does not thicken. I'll explain why. I try to put these in a way that they're like positive, like we want to say, good, we passed that. So do we say we don't want any outliers? We don't want outliers. That's correct. Does that work? Yep. We don't want outliers. We don't want to find any. We don't want extreme outliers because those outliers right there pull the data in that direction. Then we're explaining outliers and instead of explaining the data. So we don't want to explain outliers. We want to explain all the data. We'll draw our good and our bad example here. We'll draw another bad example because people often think plot does not thicken means one thing. So I'm going to make this one a really awesome regression. You don't usually see something this great, but this would be like everything is perfect. That is amazing. Like that, don't look at this one point. I'm going to highlight it. Don't be like, aha, there's one outlier. No, nothing's perfect. That's not even perfect. But now we're going to draw 2 bad examples here. These are our 2 bad examples of plot does not thicken. So of course you don't want to see it get thicker like this. That's bad too. That means the predictive power of the model is decreasing. As you can see right here, the model is getting wider as it goes out. So the predictive power of the model is getting weaker. Let's not put those happy green lines on it. Let's put these angry red lines on it. And so the predictive power of the model is getting worse. The predictive power of this model stayed relatively similar, very, very similar. But now we're going to draw an example right here where it does, whoops. We're going to draw an example right here where it does the following. Now, someone might say to me, Brian, this is good because the plot does not thicken, it gets thinner. But when you think of it as the way as the model should stay relatively the same strength, this also fails because the model is getting stronger as it goes across. You don't want the model to have a differing strength, what we call heteroscedasticity. We want to have what is called homoscedasticity, or same strength throughout. So if you notice right here, we just did the 3 conditions for correlation, but if we do 4 conditions, these are the 4 conditions for regression. So I want to make that very clear that there are 3 conditions for correlation and there are 4 conditions for regression. And these are the 4 conditions for regression. QQ straight enough, no outliers, plot does not thicken. Does that make sense to everybody in the chat? Doing great with those 4 conditions for regression. Now back to some calcium in the water. So I like this question right here a good bit because it shows you output. And if we notice what's going on right here, someone might say to me that doesn't look super strong, but here's the thing. It gives us the correlation later on, I believe. R squared, yes. Whoa, mine is crazy strong today. 96% of the variation is explained. You're welcome, Lindsay, of course. And so this is a very strong, actually. So it's a fairly strong negative linear relationship. Towns with harder water, which is more calcium, tend to have lower mortality rates. So as calcium, let's just zoom in on this a little bit right here. As calcium is going up, mortality rates are going down, and calcium makes water harder. So it's calcium in the water, yay. So continuing on, we see that R squared is 96%. We see S, we don't need to worry about that. I think there's one tricky problem which talks about standard error, which I should remove. More on that later. And right here we see the intercept is this. Please note that this looks a lot like your jump output. Do you see this table down here on the bottom? I'm going to show them both at the same time. We'll get it on the screen right here. This table down here on the bottom of this screen right here looks just like this table down here. You'll see you've got coefficients, which are estimates. You've got standard errors, which are uncertainty. We don't cover that in this class. You've got t ratios, which is the ratio of your estimate to your uncertainty. So 18,000 divided by 600 is the t ratio. And you've got your p-value for the intercept and p-value for the slope. The only things you should know on the test related to this output are the estimate of the intercept, that's your B0, which I'm pointing at right now, which is also right here in this example, and the estimate of your slope, which is the one connected to the x variable, which is right here, that is B1, and this is B1 here. And then over here, we have the significance of the model, which is the significance of the slope. Why is it not the other p-value? Let's explain. The p-value for the intercept changes the intercept of the model. The intercept is not the xy relationship. The slope is the xy relationship. So when we want to see that something is statistically significant, we want to see that the relationship between x and y, which is governed by the slope of the line, the slope controls the xy relationship, is actually statistically significant. Now, we're not going to say it causes changes, but we can say that there's evidence of a statistically significant association, and it's due to the slope, because the slope controls how x and y relate to each other mathematically. The intercept is part of that equation, but it doesn't control kind of the way in which they relate. That's the slope. The intercept is just pretty much an arbitrary point which helps us calculate like distances from the intercept to give a mathematical equation. Okay, so we know what we need to know in this output, and we're good to go. So let's take our output, and we've got to take B0, excuse me. B0 is going to be this right here, so we're just going to take B0 and drop it right into there. Then we're going to take B1 and put it right into here. This is a good problem for practicing knowing what to get out of your output. So kind of know what to get out of your output. So now we need to interpret. Don't look at their interpretations, do your own. For each 1 unit increase in calcium, we would expect the mortality of a town to drop by 4.209. So for each additional point in calcium, the model predicts a drop in mortality of this. So because it's negative, we should see a drop. Explain the y-intercept. When x is equal to 0, we expect y to equal b0. When calcium is equal to 0, we expect the mortality rate to be 14.17 on average. You can throw in the on average. See, they didn't even do the on average today. It's no big deal. So the model predicts that a town with 0 parts per million calcium will have a mortality rate. And remember, this is when x is equal to 0, we expect y to equal b0. Notice the format and practice. Don't look at their answers. If you really want to super prepare for the test, write down your answers just like you're taking a test, and be prepared to write answers for interpreting the slope and interpreting the intercept. I see a lot of points lost on those questions on the test. The largest residual has a value of 73.4. Explain what this means. Remember back from our residual talk earlier on today. When we talk about a residual, we need to remember that a residual tells us how far an observation is above or below the line. So we see a negative relationship like this, and then we see a point with a residual that's like 73. That means that that town was higher than it was predicted to be because the point has a positive residual. So positive residuals means the town had 73.4 more deaths than the model predicted. Also, we have some context here because this is per 100,000. So don't forget the context, or I believe you lose the points because there's the context of 73.4 more deaths per 100,000, which is the units of the problem. The hardness of a certain town's municipal water is 130. Use this equation to predict its mortality. So now we're going to plug in X right here, and we'll complete this problem. And then I'm wondering if there's other ones. And so that's got that. Hope I didn't type anything in wrong. 870.463. Please in the chat tell me. How's chat doing today? What I hope I didn't click up wrong. So easy to make an error. Explain the meaning of r squared. Please remember, we've got our interpretations. I can't reiterate enough to you to practice these interpretations. Write them down. My class has a note-taking quiz of writing down these interpretations. So my class has a note-taking quiz where you have to write these down. But think of this. R squared is 96. So 96% of the variation in mortality rate, because mortality rate was Y, is explained by the variation in the calcium in the water. 96% of the variation in mortality rate is explained by the variation in the calcium in the water. Let's go back. And the only one that looks like that is the following. 96% of the variability in mortality rate can be explained by the variability in calcium in the water. And we got a 100. Whew. When we missed that one little one because we didn't do all the work, oh, man, that was a bummer. So what other questions were there? I'm trying to remember. I think some 474s, 96% of the variability in mortality rate is explained by the variation in calcium water. Boom! Julio, another 1,000 points. Keep it up. I know, that's all right. No, it's on the test. It'll matter if you write fast enough, which there's a lot of time. So amazing work right there. Amazing work. That's got that. I think, did we do every question everyone wants? Good stuff. How many people do we have watching? I haven't even looked at this at all today. How many people are currently watching the live stream? Got 9 people watching. Awesome stuff. I'm looking at the analytics on it, and it shows at one point we dropped to 0, and I have no idea why. It's like, at one point, everybody stopped watching you. Is when I took the call from Darren? Oh, man. Never take a call from him again. Okay. I think 474 wanted me to talk about number 5 on the most recent homework. So I might do that. Yeah, 17. 17 is awesome to think that we're doing these online office hours and we got some people jumping in, checking out what's going on. Really glad people stop by and say, okay, let me look at this. Let me see if I can get some help here. I'm going to jump into this. We're going to talk some R here. So we are going to talk some R now. And so we did some with the regression solver. So for people wondering, there's a lot of problems I did where you have to type it into the regression solver. If you are given the, oh man, thank you guys. Thank you, Julio. The homework is, yeah, we'll extend it. We'll put it, I'm going to send reminders tonight. So Abby, we do have more time. Be emailing me questions, take screenshots if you get stuck on something. Great work. This is a tougher chapter. Practice your interpretations, practice the R squared, all that good stuff right here. I'm going to drop some hints for some 474s right here. But great work, Abby. Thank you everyone for being here. Awesome, awesome stuff. So this one right here, question number 5. Oh, cool. Yeah, I know this one now. How much do I want to do of it? So let me run the top part of this and load in the Kroger data set. We got Kroger loaded in. Okay, so let's see this right here. I think I'm going to write the skeleton for this. So what we need to do is, just for the moment here, you should be working the other problems, but I'm going to talk about how to do this like with a skeleton right here. We need to figure out the fraction right here. So make sure you work the other problems. These are just hints. I don't want to overwrite Kroger. I want to take Kroger and store it into fraction and go right here and do Kroger. And now we've stored Kroger into fraction, kind of made a duplicate of it. So if you notice just here in the corner, and one of these days I want to annotate on the screen, but you have fraction is just the same as Kroger because I basically just duplicated it. So we're good on that. So I'm going to give you guys a skeleton right here, and you should know when I talk about what a skeleton is, that's the inner part of a for loop. So you're going to kind of get the code right here to get what we need to do to make your for loop. And then you just need to think about what you need to loop over, and you'll be good. So let's go right here, and let's write a code. Let's write a code that does the following. We're going to write a code that goes to Kroger and goes to the first row in Kroger. Now, these are the items people are buying. So we're seeing the amount of alcohol they bought, $1 on baby item, $555 on cooking. Wow, that's a lot of money on cooking items. $390 on drinks, $487 on fruit. These are all the purchases made by the individuals. But let's go here and do dividing by the sum. And you can see what we get right here. We're going to divide by the sum of what this person bought right here. So we're going to take the divide by the sum, and all this is going to do is give us the sum of what they bought. And guess what we get right now? We get all of these in fractions, which is the goal of this. It wrapped the screen a little bit, just so you can see right here at the very bottom of my screen. But maybe it'll look better if I do this. I don't know. There's no way to make it look perfect. But this right here is the fraction of what people are buying. As we saw, this individual bought a lot of. Let's print it to the screen again. Maybe it'll look a little nicer. There we go. That looks way better. This person bought a lot of cooking, a lot of drinks, a lot of fruit, and this is the percent because we're dividing what the person bought by their total. And now all we need to do is we need to go over here and go to fraction and store into the first row in fraction. Now the reason we created the reason we created fraction from Kroger is so it had the same dimensionality to it. We could have created a data frame with NAs in it or something like that, but it was just easy to say, let's make the same sort of thing, but in it, let's put the fractions. So let's just duplicate it and then overwrite it. Many ways to do code. So right here, you'll see what have we done. If we go to fractions now, well, let's open it up. The first row in fractions, did I not run it? Unexpected fractions, ones, Kroger. What error did I make? Oh, haha. Did not put my arrow. And so now we go to the first row, and you'll notice it looks all different because these are now fractions. These are percentages. A lot of them are in scientific notation, but we see here the percentage of cooking and drinks, but nothing else has been changed. Well, from here, all we need to do, there's 2,000 rows, so you just need to sit here for the next 3 to 5 hours, depending on how fast you can type. Change this to 2, do that, okay. Then we go here and we change this to 3, and then we do this. Change that. Okay, go here to 3. Okay, good. Do that. And if you notice, as I do this each time, you'll be changing each row. I've changed the 3 rows. So spend the next 8 hours just changing those numbers, or know how to make a for loop. I'm not going to make the for loop for this one here, but that should get a lot of people jump started on this question. But this one right here, good question. Get the for loop going on it. That's just going to go through and change what I was changing. I pretty much have given it away. If you know how to do for loops, you'll be like, oh, I know, we just need a placeholder. We just need a vector it's going to go through. Just kind of look over at here and think where it's going to I can tell you where it's going to start. It's going to start with what I started with. So you can think about what your for loop's going to start with. You can think about what it's going to end with. Hint, hint, hint. No, not saying, but. And then you just think about putting in placeholders, and then you just throw it into a for loop. Once again, that's the skeleton, which is the inner part of a for loop, which is the code just runs repeatedly as the placeholder. There are no placeholders in that right now. Changes. Knowing how to write a for loop, we always write a for loop by not writing a for loop. We write our skeleton. We get it to work one time, and then we make it so it changes. Just so people can see, I'm just going to go away a tiny bit more. When I debug for loops, a lot of times if it has the placeholders, I'll go outside the for loop and I'll go right here, and I just call this manually running a for loop because I'm doing the task of the for loop right here. And if you notice, I can manually do it by putting in a placeholder and changing what it is. So this is a manual running of a for loop. It's kind of an in-between step to make sure it's working because we don't want to sit there and change I. Now that is quicker than before when I had to change all 3, but a for loop is way quicker. And of course, if you know how to code, you'd be like, got it in the for loop, throw it through the vector, done, saved everything. But good job starting on this early. It is 5 p.m. You know what? We're going to let Crash lead us out. So thank you, everyone, for coming in, and send me those questions if you got them. See you in class.
Yeah. 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 Yeah.